Okay, we're grading a little quiz that we took yesterday, and the first question of that quiz was like this. Y equals, and I should probably make my marker a little smaller here, hold on. Y equals 3 cosine of 3x minus pi. Now, in grading this quiz, the first thing I want to grade is, did they notice that they had to factor out the 3? If they did not factor that out, they're going to lose a half of a point. Oh, okay. I'm going to pause for a second. Okay, I know there's going to be some people that are going to lose this half of a point, but I did warn you that you needed to factor that. If that isn't anywhere written on the page, then you didn't factor it. So you need to do that. Half a point off, they didn't have that. Next thing, check. Regular cosine. Regular cosine looks like that. And that's a pretty bad drawing of it, but I'm going to try one more time on that. It's got to be at its high spot, and then it's got to go back up to the high spot. There we go, close enough. Now, these spots, which would have been 1 and -1, are now changed. This is also worth a half of a point. This is now has to be a 3 and a -3. If they didn't do those two, put minus a half. Now, next thing, this is important. Would you please, anytime you mark something wrong, like for instance, if they didn't have the 3 and the -3 there, put minus a half and then write in what the right answer was. Let me pause for a second. Okay, we're back to it. So, that's worth a half a point for factoring, a half a point for having the 3 and the -3. And the last part is the numbering along here, which started at 2 pi, pi over 2, and 3 pi over 2, and has been changed to, well, this 3 here tells me I should multiply everything by 1/3. Why? I could give you the explanation, because period is 2 pi over b, and b is 3. So it's periods 2 pi over 3. See how I had to multiply by 1/3? Multiply by 1/3, by 1/3, and by 1/3. That should be pi over 6, pi over 3. 3 pi over 6, and yes, I'll accept that, even though it could be reduced. And last is 2 pi over 3. If they don't have those 4 numbers, they lose a half a point. Say minus a half numbering, or you could say it's based on the fact that it was supposed to be shrunk. And if they don't have those numbers right, they didn't shrink it right. Try to move it up. I see a lot of people like training to see that. Okay, and then last but not least, it's been moved. Now this part I'm not going to grade because I don't want to put too many points on one problem. But I hope you know it's been moved to the right pi over 3. How far is pi over 3? This is how far pi over 3 is now, because see, I numbered it and it's pi over 3. So it's 2 marks over. If they moved it over 2 marks, they were right. But don't grade that part. I'm trying to focus on other problems too, and I don't want too many points all off the first question. Any questions about how to grade the first question? Just to clarify, some people are like, so how many points is that? It doesn't matter. If you didn't mark any wrong, they still have a perfect 10. They have a 10 out of 10 right now. Okay, and anything you mark wrong, it brings their 10 down. It's called spot checking. All right, moving on. Would you read me problem 2, please?
Y equals -2 cosecant pi x plus 4.
Notice how he said -2. Everybody look at that. How many of you noticed that there was a negative there?
Oh.
5 people. A what? There's a negative there.
Why is it like up there? Someone added it after.
No, nobody. Oh, yeah, sure. I went through and added a negative to everybody's worksheet.
Now we thought it was a computer glitch, sir.
All right. Now, enough people had trouble noticing that negative that I am going. And this is not going to happen in the test, by the way. If there's a negative, then you have to reflect the negative. But a lot of people didn't see it. I'm not going to grade it. Like I said, I'm spot checking. I will let that part go. But yeah, there was a negative there. Would you read me the rest? Pi.
X plus 4.
Okay. Next common mistake, and I even caught myself doing this once, was I thought, oh, I'll factor this. Well, why am I not supposed to factor that? There's no parentheses. That's not all on the inside. Okay, so that should not be factored. All right, next, draw this, and I'm going to say, what is cosecant anyway? Well, it's the sister of sine. So I'm going to graph sine quick, and then Wherever it touched 0, that's where the asymptotes would be. If they don't have asymptotes at 2 pi, oh wait, that's going to get stretched in a second. So wait just a second to judge where those asymptotes are. But that's pi over 2, that's 3 pi over 2. They needed asymptotes, and last but not least, they needed the loops. This and this, that, the green thing, that's actually the cosecant graph. All right, next is these spots used to be at 1 and -1. I want you to take off a half a point if they didn't change it to 2 and -2. Okay. Now, I know some of you are going to be like, but wait, they moved it up a whole bunch. We're not going to grade the move up. It's too complicated. But if they didn't change their numbering on the y-axis, then they didn't reflect this fact that there was a 2 here. Okay? That's a half a point. And you can put minus a half. Jeez, you okay? That's impressive. Okay, anyway. Next, period equals 2 pi over b. But what's b? That's weird, but b is, you see it? It's pi. So what's 2 pi over b? 2 pi over pi. So everything, like the 2 pi, needs to be divided by pi, or multiplied by 1 over pi. And a lot of people got confused by that. A lot of people are going to lose this half a point. That cancels, that cancels, that cancels, and that cancels, leaving 1/2, 1, 1 and 1/2, also known as 3 over 2, and 2. If they didn't cancel off their pi's, they lose a half a point. A lot of people are going to lose that half a point.
What if they drew their graph like this?
Irrelevant on how they drew the graph. Right now, it's grading the labels. Now, it's a good question. What happens if the curves are wrong? I haven't asked you to grade the little curves yet, because there's 2 places they could be. They could be where the green curves are right now, or they could be flipped because the person was smart enough to know there was a negative there, or they could also be moved up. So I'm just going to purposely not grade those little green loops. But I am going to check, did they have the asymptotes in the right place? If they didn't have asymptotes at 1, 0, and 2, then they didn't do it right. So check for their asymptotes. If the asymptotes are not at 0, 1, and 2, they're going to lose a half a point. Okay, enough about that problem. Moving on. Problem 3. Okay, so problem 3 is y equals 2 tangent of x minus pi over 2. Okay, here's me doing tangent. Doesn't have to take a long time. Zip, zip. Asymptotes. Is that tangent? Is what I just graphed tangent? No. What is that thing that I just graphed? It's the most missed kind. That's cotangent. Cotangent is shifted over a little bit and goes the other way. All right, that's cotangent, just so you know. Back to regular tangent. Regular tangent goes like this. It's the more logical one. It's got symmetry across the origin. All right, there's tangent. But normally, isn't there a 1 and a -1? You should know that. Yes, there is normally a 1 and a -1 spot. So what is there now? It's been stretched. A 2 and a -2. Half a point for having labeled those as 2 and -2. A lot of people lose that half a point because they forget the y-axis labels. We want them to remember that on the test. 2 and -2. Okay, and then this right pi over 2. Everything, including the asymptotes, has to move right. And how far is pi over 2? This is pi over 2. So it's that far. Everything has to move that far. Okay, you could argue that that's 2 marks on your graph. All right, so it needs to move over 2 marks. I'm going to draw it over again and show you where tangent has moved to. everything got moved over 2 marks. Just to clarify, think about this dotted line right here. Wouldn't it have moved over right on top of the line? Yes, it would have. There's now an asymptote here, and there's now an asymptote here. And the asymptote that was at pi over 2 has moved over 2 marks, so it's now at twice as far, 2 pi over 2, also known as pi. If they don't have a 0 and a pi right here, then they didn't do it right. Check for their asymptotes at 0 and pi. And if they're not there, go -1, asymptotes at 0 and pi. And then tangent runs this way. And the only thing I got to do is have that 2 and the -2, have these asymptotes labeled at 0 and pi, and then it's already been shifted. I've already done the shift to make it go to the right pi over 2. So there's my final answer. Okay. Half point for the asymptote, half point for these spots.
Oh, I thought you said point.
Then last is cotangent, number 4. If you had to graph y equals cotangent, well, first thing I would do is remember that it's not just like, here's tangent, and then I flip it backwards and that's cotangent. That's not right. Its asymptotes move. Okay? Its asymptotes are in a different spot. If you were doing it that way, stop that. The cotangent goes like this. Because do you remember the other one went through 0? Because it went through 0, cotangent can't exist there. That's why it's shifted over. There's your cotangent graph. And since these are always, do you remember, unless they've been stretched, they're always pi apart. Does that ring a bell? That's pi, that's 0, that's pi apart. Check for their asymptotes being at 0 and pi. They don't move. No, wait, actually they will move. I'm sorry, they will move. Because it's not just cotangent. It's cotangent of x plus 3 pi over 2 and then -1. We're not going to grade the -1 part. We're just going to grade, did they shift it correctly? Left 3 pi over 2. Well, here's normal cotangent, and everything needs to go left, including the asymptotes. Everything needs to go left 3 pi over 2. That's 1.5 pi's. Okay, so I'm going to just do those one at a time and show you. If I take this curvy thing, the spot it touched right there, and I go over 3 half pi's, 3 pi over 2, then the curvy thing is now over here. And the asymptote, which used to be here at 1 pi, has to go over 1 pi and a half of a pi. So that asymptote is now here at -1/2 pi. And then there's one more asymptote, and that's here. And that's where this asymptote has now been shifted. It was at 0. It's gone to -3 pi over 2. It's gone over 3 half pi's to the left. So if they didn't shift theirs properly, take off 1/2 a point. That was a whole bunch of chances to take off 1/2 a point. If there were no mistakes, of course, they have a 10 out of 10. If they have 4 little half points off, please be clear with them what was wrong. Because if it's messed up, the first call for help is you. So everybody at the bottom of the page, please put CB and your name. And if they ask you, why'd you take off this half? Don't just change it for them. Tell them, okay, let me think. What did I do wrong? What did you do wrong? And then tell them why it's wrong. Ideally, you'd tell them why it's wrong right now while you're grading it. All right, just give them a score out of 10. At the top, at the bottom, put a CB in your name. That's all I have for this part. I'm going to pause. Okay, so another kind of problem you need to be ready for on this next test is this kind where you're given a wave. And I tell you that spot, excuse me, CW, zip it. All right, I'll move in a second. You got a wave, and this starts at pi over 6, and it goes up as high as 10. And then it goes to 3 pi over 6. I am making that on purpose, a nice common denominator for you. You could have done that yourself, but And then let's say that the low spot's at 5. Now, you should be able to tell me everything. You can tell its period. You can tell its shift. You can tell how far up it's been shifted. And I would always start with this little line. Does anybody remember the name for that? Midline. Very good. Then, write the cosine equation. Always use cosine. Write the cosine equation for that. I'm going to pause for a second while you give this a shot with no help from a partner. I hear what you're saying, and you're thinking, maybe I should make this a sine graph. Never do that. It's a heck of a lot easier to tell how far this peak right here has been shifted from 0. That shift right there is so much easier if it's cosine. I used to think the same thing. I used to think, maybe I should make this one out of sine. Then your shift becomes a lot harder. All right, I'm going to pause for a second. Let me give that a try. Something that you know. Tell me something about this.
Is that me?
No, there's a lot of them, but I poked them on the arm as I walked past. So, yes?
The amplitude is 2.5.
The amplitude is 2.5. He is correct. There's a 2.5 right here. Why? Because from here, the midline up, the midline's at 7.5, and from 7.5 up to 10 is 2.5, so he's right. All right? How about you? Tell me something.
B is...
Ooh, she's trying the hardest part. Period is 2 pi over b. Now what?
Yeah, and B is pi over 3.
She's saying that b is pi. Are you sure? Do you mean the period is pi over 3? Or do you mean the b
I
is...
mean B.
Oh, okay. All right. So first tell me how you figured out the period, because you'd have to get that first.
Well, it's basically just like, I'm going to use physics terms here. It's just like the wavelength, the distance from the top of one wave to...
All right. So from here to here, you're saying. From here to here. I would agree that that is the period. But I'm not sure that your final answer is right yet, so let's make sure. How far do you think that is? From here to here? The period?
2 pi over 3. Oopsies.
All right. All right. So it's 2 pi over 6 from here to here. And I'm going to double that and make it 4 pi over 6. I'm going to call it 4 pi over 6. And you called it 2 pi over 3. They're the same thing. All right. Now those two are equal because I changed the period out for 4 pi over 6. Again, I like to do that this way. 3 pi over 6 minus pi over 6 makes 2 pi over 6. Double it, 4 pi over 6. Why double it? Because you're only going from here to here. You need twice that far to complete the cycle. Okay, finally, 2 pi over 3 equals 2 pi over b. Can you just look at that and use logic?
Yeah.
Do you see that b has to be 3? See if 2 pi, 3, that's got to be 3. So b equals 3. Or you could do a long process of solving, and it turns out b is 3 either way. So b is 3. Now, how about the shift? Do you know that kind, sir?
Yeah, the shift is going to be right pi over 6.
Right pi over 6, because that's how far you have to go to get to the first peak. So minus pi over 6. You are so right. And then the last part, CW.
Is it 7.5?
Plus or minus?
Plus.
Plus 7.5. You're correct, sir. It goes up the midline. Okay, awesome. Now, there's different variations on how we could give you this data. Do you remember on one of the homework problems, they just gave you a big XY chart? XY. Let's say I said it started at 1 and I got 0. What? I'll give you a little more data. 2, I got 1. 3, I got 2. 4, I went back to 1. 5, I went down to 0 again. Do you see what's happening? Cycling around between what's the lowest it ever is? 0, and then what's the highest it ever is?
2.
The highest is 2. Goes between 0 and 2. So can you turn that into a graph that goes this way? I can. 1, 0 is here. 2, 1's here. 3, 2 is here. 4, 1 is here. 5, 0 is here. Do you get what's happening here? It's like that. And it's just going to keep going. except it's probably not going to ever go below 0 because the lowest it ever was 0. So it's probably going to bounce back up again there. Okay, so moral of the story, I have turned a table into a graph because to me a picture's worth 1,000 words. I'm going to then say, oh, I can see the midline. It runs through there. And then it's not that hard to do. But if you do it just from the chart, it's not easy. Turn the chart into a picture. Now, answer the question. What is this one? Use cosine again. Better figure out how high it went, how low it went. Maybe find a high spot and a low spot and use those points. All right, I'm going to pause for a second. This is the challenging part where you got to engage that brain. Okay, did you figure out? A lot of people get these things backwards. Did you figure out the highest it ever went was 2? And the lowest it ever went was 0? So where's the midline at? 1. So it's 1 cosine. Do you have to put a 1? No. 1 cosine just means cosine. And then I need to find this b term. How do I get that b term? The b term there is, I have a formula for that. Period is 2 pi over b. I don't know b, so I must know the period. How long does it take to go from a low spot to a high spot? And then I'll double it. It takes, well, this is at 1, this is 2, and this is 3. It's 2 to go halfway, so it's 4 to go all the way, so its period is 4. A lot of people will mess that up. It's not.
Thanks,
Here's your problem. You're thinking, oh, from 1 to 5, that's 5. When you count from 1 to 5, that's actually 4 stops along the way. All right, so total of 4 for the period. So then what's b? b is 2 pi over 4, which reduces to pi over 2. So b is pi over 2. That's going to separate the a's from the b's right there. Because you're going to have to probably do this twice. Pause for a second. All right, so now we got pi over 2 in there. Then we got a theta. And then the shift to the right, that's not too hard. I think even you could handle that.
Okay.
What do you think?
I think it's 1, right?
Okay. So the high spot?
Oh, not the high. Oh, it's 3, right?
All right, there you go. So minus 3 is correct. And then last but not least, the easiest one of them all. You got it?
For the amplitude?
Nope, I already done with the amplitude. I'm looking for this number here.
It's not
It's plus what?
0.
Not plus 0.
0.
You're thinking maybe that this keeps going down below the line here, and it doesn't. I'm going to have to shift your reality here. This is what this graph looks like. It goes back and forth like this. So the midline is there, so it's shifted up 1, so that's a 1. I know, it looked like it was a sine graph that was going to go down underneath this, didn't it? But it doesn't. The lowest it ever goes is 0, see? Look, a normal sine graph will go down to -1. So this one, its midline runs right down the middle. That was at 1. So the midline, this number, is this number. Okay? All right, yes.
How do you know that it doesn't go down to -1 after that 0?
Because in real life, negative is impossible.
All right. And I do get what you're saying. On the test, you will get tons of data, and you'll be able to tell for sure what the lowest spot of them all is. Okay? You do have a good point, actually. I don't want to keep going on it, but you'll have enough data where you can easily find the lowest and the highest, and then you go from there. All right, enough about that. I told you this was coming, so let's see if you're good at it still. The circle trig. Who can do cosine of the angle is -√3 over 2, and it's in quadrant 3, and what's tangent? By the time you've drawn the triangle, and you got all the sides on it, If you've labeled it in the right quadrant with all the sides and you haven't made the most common mistake in circle trig, then it's easy. I'll pause for a minute while you give that one a try. 12-minute warning going off. All right. You should have drawn it here. Cosine's adjacent. Hypotenuse. What's the other side? You can do this whole thing, but you can just remember this is the 1, 2, root 3 problem, so it's got to be a 1, except a negative 1. Very good. Most common mistake in circle trig is forget that negative right there. Tangent, TOA, opposite, over, adjacent, and therefore the negatives will cancel. 1 over root 3.
That's the review base.
That's the type of question that you have to know how to do. There are other types of questions that you'd have to know how to do, but from my experience, this is the hardest kind to remember. Circle trig covers so many things. To do this, you had to know where things are positive and negative in each quadrant. You had to know sides of a right triangle. You had to know certain ones that were memorized, like 1, 2, root 3, or the quadratic formula. Not quadratic, sorry, the Pythagorean theorem. You had to know what tangent means, like opposite over adjacent, etc. There's so many things this reviews. So it's actually a pretty smart thing for teachers to put on the test because it makes you remember a bajillion things, and touching it once in here means it's going to be so much easier to remember it on the final. Because otherwise, if we hadn't practiced it right now, and then all of a sudden the final comes up in 6 weeks or whenever it is, it's going to be much more painful. So the review we do will help you a lot. All right, then one more thing. Let's go back to a different kind of sinusoidal. It's not a chart. Remember when we had the chart and I had to just find the low spot and the high spot? What if it's a story? All right, this is going to be about a whale. The whale has to keep coming up to the surface, right, to breathe. And this whale decides for a while that he's kind of bored with just being a normal whale, so he decides to be a sinusoidal whale. And so he's going to go back and forth between 20 feet under and the surface. 20 feet under and the surface. And because they're extra smart, he times himself. And it takes him about 30 seconds to get all the way from the surface down to the 30 feet. He's going kind of slow and gentle. What? 20 feet down, sorry. 30 seconds to go 20 feet down. And he's just going really slow. And then he kind of cruises at that and starts coming back up again, gets some air, and it creates a sinusoidal. It just keeps going back and forth between the surface and 20 feet down, surface and 20 feet down. I'm telling you a story. Now you should be able to write a cosine equation for that sinusoidal whale. It's better than the suicidal whale, that's for sure. Did you see the whale that actually ate a person by accident? It was a diver.
I saw the picture.
They were saying it was like a real life or a modern day Noah. No, not Noah. Who's the one that got ate by the male? Jonah. There we go. Because this guy was in a whale's mouth. He was like,
Did he die?
he did not die. I think he spit him back out.
Wait, does it start at 0? Starting surface does it start at 0?
All right. So
Nemo. I just missed
you got a good point. I should tell you where the high spot is. He starts, we're going to say he starts timing himself when he's at the surface. He's just taking his breath and he's about to go down. That's when he starts timing himself. So you can start this whole thing with the whale at the surface. Sure. I knew this problem was too hard for you. Oh, I sure you did. Okay. I like drawing pictures. Because I think a picture's worth 1,000 words. That's what Einstein said. But he's not very smart.
He's dead now.
Yeah. If he was that smart, he'd still be alive. All right. Anyway, if we say that he started timing himself at the surface, he was at 0 at the surface. And then that means at that moment, he would have been at 30 seconds to get all the way down to the bottom. And the bottom of his little sinusoidal cycle there was 20 feet. There, I drew my picture. Now I can do the midline. It helps so much. It tells you two things. It tells you the beginning and the end of your sinusoidal. It tells you the A and the D. Would you agree the midline's at 10? Negative 10. Very good. How many of you forgot to do this all in terms of negatives? You may want to fix that. Below the surface, that is a negative.
Wait, would the peak be negative?
Do you have a question, HT?
Oh, would the altitude be negative?
I think you mean amplitude.
Or yeah.
Okay. The amplitude isn't necessarily negative. The amplitude is from this line up. So you always make your amplitude positive. Now, if you think the graph's been flipped, then you can make it a negative, but that would be for a different reason. It wouldn't be because we're underwater.
How do you determine if it's been flipped?
It's a good question.
You just have to tell you.
We'd have to tell you, because you can't tell otherwise. You're right. All right, so we're going to say that this one has an amplitude of 10. Would you agree with that? Question?
I have to go now.
I understand. All right. So we're going to go with 10 for that amplitude. We're going to go with it's been shifted down, negative 10. And then this is theta. And then have a good day. Make sure you're ready for the test tomorrow. And don't forget, there is an assignment. The assignment is that Schoology quiz. It was assigned yesterday. And I told everybody, hey, you could start on it, or you could make your later you do it.
Okay.
If you haven't finished it, get it done by tomorrow at 8 a.m.
Thank you.
All right, have a good day. Last but not least is the shift. Oh, wait, no, that's not last. The shift is pretty easy. It's how far is the peak? Well, the peak is at 0. It isn't shifted at all. Or I would also accept this. This is kind of weird, but true. You can notice that there was no shift here and put plus 0. I'd accept it. Or you could also say that that's the first peak we encounter, and therefore 60 seconds and plus 60. Yeah, you can do that. Because you know what? That's its period, and that's like adding 2 pi. Goes around the circle, goes around the circle again. And yes, thank you. Those are always minus. My bad. It should be a minus 60, not a plus 60. So I like the 0 idea. How many of you did 0? No shift. That was good, but you don't have to. If you, and it's okay. The safer thing to do is to do the thing I always say, which is the first peak you encounter, and that's that one. And then we'd say that that was at 60 seconds, so plus, nope, minus, because it's to the right, minus 60. Okay, and the last but not least, that's the B term. There's a period formula for that. Period is 2 pi over B. I don't know B, but I know the period. The period is 60 seconds. It just makes sense to me. The whole cycle is done in 60. If that doesn't work for you, then say from here to here is 30 seconds, and then I got to double it. 60 seconds. Switch flip-flop places. B is 2 pi over 60. I would totally understand it if you decided to simplify that and make it pi over 30. And that pi over 30 goes right there. So why was this one harder than some of the others? Because it came just with a story, and you have to make it into a sinusoidal. All right. I think that's enough practice. Now, your homework for tonight is a Schoology quiz. I'm telling you, it's going in the grade book. Do it. But here's one thing that makes your life a little better. If you can get a 75% or better on it, I will give you a straight A, as in a 100%. All you need is a 75% or better. And you get 2 tries. Not on the normal test, no. On the Schoology quiz, you get 2 tries. If you can get a 75% average, you will get a 100% in the grade book. I will be taking that quiz, and that is going in the grade book. I will be taking the quiz at the door as you leave. And that's all I got for the video for today. The quiz on your paper, the paper quiz is going to be given to me at the door as you leave. The Schoology one is going in your grade. Yes.
No, I'm saying is it resumable? Once you start it, can you like exit out?
Yes, it is resumable. Okay, just give me a second to type in today's date. Do you know what it is, Mark?
It's 21st. 21st, sorry.
Trying to mislead me? How dare you?
I know, I'm terrible.
HPC, don't do that. Give it to me at the door as you leave. Otherwise, it's easy to fake that you put it down. All right, and this is...
It's kind of boring if you